Hello and welcome to this podcast for Electropages. I'm your host, Robin Mitchell. Today we have a guest that we saw previously at PCIM and saw some pretty interesting stuff. So just before we get into all of that, please tell the audience who you are, what you do, and what you like to do in your free time.
Hey everybody, this is Andrew Plummer. I'm a product marketing engineer at Texas Instruments in our high voltage power group. And in my free time, I like to play sports, watch TV shows and movies, whether it's, golf, basketball, and more. Thanks for having me on. It's great to see
Fantastic.
You guys again. Look forward to the chat.
No worries. Anyway, great to see you again because we saw you guys at PCIM and we saw some really interesting stuff. So could you just tell the audience what we actually saw last time we were there?
Yeah, so we had a variety of demos available at PCIM in Germany, and there's a lot to be excited about. One of them, was our 48-volt buck converter demo. We had a full-scale traction inverter on display, and some also DC to DC converters based off of our gallium nitride technology. But one we didn't get to spend too much time on that I'm really excited to spend a little bit more time on today, which I'm a little closer to, is a 750-watt light electric vehicle charger. So this is for like a kick scooter or an e-bike, a motorcycle scooter. This is a product, that has been rapidly growing, in our industry. Electrification is not just something that's happening, for cars and trucks. It's also happening for smaller vehicles and And one of our LLC controllers, the UCC 25561-Q1, is an exciting product that I want to, talk a little bit more about and kind of dive into.
Fantastic. So that is quite an interesting area because we tend to see a lot of, like you say, we tend to see a lot of large chargers, EVs trying to pump as much power as they possibly can to get these things charged in the shortest time possible. But I think it would be fair to say that that's one market I've not really seen much growth in, or in terms of like development in. So would you say this is a rather new industry?
Yeah, I would say relatively speaking to the automotive industry and EV industry as far as cars is concerned, I would say electrification as far as what I'll call light electric vehicles or electric 2- and 3-wheelers is pretty new, but it's something that's rapidly growing, especially in Asia.
And why do you think it's growing so fast?
Yeah, I think that as far as the benefits that electrification it can provide, there's a lot that scales and works sometimes even better for these kind of smaller vehicles. You can think of like a last mile shipment or a last mile delivery. If you're somebody who just for the sake of argument is working for the postal service and you need to get around to all these different locations and there's lots of traffic, having an electric vehicle is really helpful, of course, right? Because when you're sitting there, you're not creating any emissions, and you can also have your vehicle charging, kind of wherever you are. You can bring your charger with you, and that's not something you can, really do with, an internal combustion type vehicle. So I think the portability, the ease of use, and then also, the kind of carbon emissions, like climate aspect to it, are all things that kind of help in terms of contributing to the growth of the light electric vehicle market.
So when you talk about these sort of scaled down power chargers, which can still provide a lot of power, are we saying that these things will be integrated directly into your scooter or your small vehicle?
Yeah, so there's kind of a whole ecosystem that's available right now, kind of a whole spectrum of opportunities. So I see three main architectures being used, and kind of the newest and most, I would say, premier of them is actually integrating the charger into the scooter itself. What's more common and has been used a lot more frequently, but what's rapidly changing is basically taking the charger from a portable scooter that you can bring around physically, like your laptop adapter or charger, to integrating those electronics into the scooter itself. And another really common solution for this kind of problem is battery swap technology, and that's where you can there's stations that you can go to, physically bring your scooter, and they design the scooters in such a way that it's very easy to physically take the battery out, place a new one in, and off you go, without having any need for charging. And I think it'll be important to kind of have both those options, because we've seen kind of both of those solutions kind of develop in different regions. So I think at some point it's kind of a customer preference thing.
And it kind of makes sense when you think about sort of like inner city travel, when you want to get to one side to the other side. You don't want to go by train because it might be too too expensive or too difficult to get to, and you don't want to go by car because you can't even drive through it. So the idea that you could have multiple power stations on the way from your scooter journey, it's effectively as quick as a car because it has to use the same roads, and cars aren't going to be going quick. But then you need that battery swap technology to be able to get the range. Otherwise, you'd have to keep swapping scooters along the way or charge somewhere and wait. So what would you say is the biggest challenge when trying to integrate those types of power supplies into these sort of, let's call them like low end, not low end, like sort of like low power EVs?
Yeah, sure. So I think, similarly to what we've seen for what I'll call traditional electric vehicles, cars and trucks, I think there's, simply speaking, a lot of like cost pressure, right? And so integrating those electronics into the
Yeah.
scooter is difficult, but I think what's very exciting is that, at Texas Instruments, we're developing, a set of products that are helping, enable customers to design with like higher power density and higher efficiency. So the kind of cost of integrating that type of solution isn't as high as it maybe would be otherwise, because a lot of these systems like electric vehicles are also getting more advanced in terms of the actual electronics that are going inside. So on like a system level, making them easy to use and also easy to scale is a really important piece of it.
And that basically means that if your hardware is too complicated and expensive to put in, it's going to be hard for people to adopt it and therefore adopt these lower end EVs. So it's kind of like a chicken and egg problem, because if you get to solve this problem, you can then try and also increase the market for those solutions in the first place, which will then further help the development of those solutions.
That's exactly right. That's exactly right. And so one way that we're doing that at Texas Instruments is by providing reference designs, which is what I was showing at PCIM, which is like a full-scale example of what a charger would look like. And what's very cool about these types of chargers is that regardless of whether it's integrated into the scooter or external to the scooter, as far as the actual charging system is concerned, it's not very different. It's more so about the mechanical placement. Of course, there's some nuances and differences,
Yeah.
but a lot of it is pretty much the exact same system. It's just uh, and then the exciting part also about the onboard charging, like you kind of alluded to faster, is that a lot of the times, because you're putting it into the scooter, you can charge at a higher power level, which, helps charge your scooter faster, which is another big draw for having, these electronics built into the scooters and mopeds and things of that nature.
And I'm guessing the kind of challenges that you tend to face, when you choose between onboard versus offboard charging, is going to be things like heat dissipation, like you say, connector size, IP ratings. They're probably more important than the actual circuit itself.
Yeah, yeah. A lot of it, is a lot like, what I would say power is in general across the industry. It's something that if you're able to provide a really innovative solution and cut down on size or really improve efficiency, it can be something that's really exciting. But a lot of the times, right, even from a consumer perspective, we just want something that works. And so that's really important to be
Yeah.
able to deliver that reliability, and also in this type of situation, the safety too. Right, so that's why we have integrated a lot of features into our controllers and other products that we offer to be able to ensure that these types of chargers, whether they're in a battery swapping station or inside of a scooter or external scooter, can operate without dissipating too much heat.
And that's an interesting point to raise, because I'm kind of interested in what you would say as an engineer. Like, what would you say is the biggest challenge when it comes to safety in these sort of modern GaN type devices, or these sort of modern switching technologies as they come out? What would you say is the biggest challenge that engineers face with regards to safety?
Yeah, I would say it's during more so like kind of the development process in terms of making sure your system is robust to a set of, kind of predetermined faults. I mean, and there's a number of factors. So one, I would say it's the environmental factors. So very similarly to cars, right?
Yeah.
It's generally got to be more resistant to like moisture, and it also has to be more resistant to heat. So maybe your circuit has to operate at a hotter temperature and be stable at that hotter temperature. In addition to, if you're driving through water, right, your onboard charger has to still work the next time you get to the station. So there's a lot of
Yeah.
mechanical pieces to that. But there's also, electrical pieces to that as well. So, yeah, that's what I'd say.
So even though, like with these small EVs, they might be small EVs like scooters, like you say, they're still effectively automotive systems, and so they're still going to be subjected to those same sort of stresses, effectively.
Yeah, that's exactly right. Yeah, and so that's why we have a lot of, what I'll call, standards or governing bodies that help dictate, what types of, tests. So, one of the things that's very common
Yeah.
is, testing our products across multiple temperature ranges as we're assembling and testing them in our factories to be able to ensure the highest level of quality and reliability.
And so does that mean then that, or do you foresee these kind of sort of markets requiring sort of like those automotive qualifications like they currently do with vehicles?
Yeah, I think we see that it's typically regionally dependent, and I think it also depends on the
Mm.
size. So I think if you're talking about, just a little kick scooter that, even a kid can use, then maybe it's, or you're using it to get around your college campus where there's like walking paths. We don't see as much need or quote unquote pressure,
Mm.
if that's the right word, to kind of have that automotive qualified material. But let's say you're talking about a motorcycle and you want this thing to be able to go, 80 kilometers an hour, or 60 miles an hour, whatever the case may be.
Mm.
That's where we're seeing a more kind of
Yeah.
stringent, you know, reliance or dependence on that automotive qualified material. And there's a bit of a regional dependence to it, but it mostly comes from the size of the system itself, and how likely it is to interact kind of with other vehicles, like on wherever it's
Mm.
traveling.
And when it comes to the battery technology used by these vehicles, I'm guessing they're going to be all lithium-ion based because it's one of the best battery solutions out there in terms of energy density. And when engineers come to utilize solutions like GaN switching, do you find that they also have issues when trying to combine lithium-ion with those types of switching technologies, or does it really not matter because the switching technology is going to be used for more high power, which then gets knocked down to some charging circuit anyway?
Yeah, sure. So as far as the battery technology, I agree with you that there's a trend kind of from lead acid batteries towards lithium ion, especially because we're seeing actually an increase in the battery voltages that a lot of the manufacturers are
Yeah.
using, right? And they're doing that because of the same reasons in cars, right? If you can get better range, if you can deliver more power, charge faster,
Yeah.
you're incentivized to kind of do that. And right, like you said, the energy density is there. As far as how that interacts with whatever switches you have in the system, especially gallium nitride or GaN. Yeah, I would agree that mostly there's not too much of an interaction between those technologies. I mean, it's important to consider the technologies of your battery pack and the technologies as a part of your powertrain. But I would say, generally speaking, they're relatively disjoint. But yeah, I would say
Mm.
that's one of the areas where, my expertise as far as the battery technology is, more limited as far as like relative to the chargers is concerned.
Mm. And so when it comes to these new powertrain solutions that you guys have been developing, especially with the reference designs, compared to the previous generation of technologies, what kind of performance increases are we seeing in terms of size, power capability, etc.?
Yeah, so in a lot of cases, and from this specific LLC controller that I mentioned before, we have some previous generation solutions which are, for 500 watts for either 48 volt and 72 volt battery systems, and now we're working
Mm.
on ones for 72 volt and above batteries, even 96 volt batteries for 750 watts, 1.5 kilowatts. So you're not only
Mm.
potentially doubling the battery voltage, you're also potentially doubling the output power of the DC-DC or the
Mm.
charger itself. And right, you don't want to have to give up a lot more space. So of course, as far as the actual power stage and bulkier components of the system, there is going to need to be some change in it, but it's not necessarily true that the power stage would double if you're going to increase the power, and that's because of some of the advancements we've made in our technology. Generally speaking, in power
Yeah,
electronics, if you can increase your switching frequency, then you can make your passive components like your transformer, your inductor, those things
of
smaller, and
course.
that's something we
Yeah.
heavily rely on, and actually is a huge improvement of our current generation or newest generation of LLC controllers and other controllers in our portfolio as well, relative to the previous.
So you sort of mentioned something that's kind of got me thinking a little bit, which is about powertrains and sort of like wattages and how much power you can squeeze out of batteries. I'm guessing a lot of this is primarily focused on quick charging because if I look at a scooter sort of design or like say a kick scooter, it's like you don't need humongous amounts of power for the wheels, and you're not trying to get 0 to 60 in 3 seconds. So I'm guessing most of this is focused around quick charging.
Yeah, I would agree with that.
And so the sort of the needs of these applications are quite different to what you tend to see from EVs, minus the fact that they also want quick charging.
Yeah, yeah. As far as the power train is concerned, yeah, there's definitely, as far as the the inverter, the piece that
Mm.
converts the electrical energy from the battery into exciting a
Yeah,
motor and actually physically driving it. Yeah, those systems are what I'd say much simpler and much lower power for a
way, way,
car.
way
We're
simpler. Yeah, they
yeah,
don't.
we're talking
Yeah,
hundreds of kilowatts versus just kilowatts in some examples. So yeah, it's
yeah.
but what's really cool about it,
Kilowatts if
right,
you're
is that
lucky.
it's yeah, exactly,
Mm.
exactly. It's really interesting to see how, even in these very different types of vehicles, fundamentally they are truly
Mm.
the same kinds of systems and the same kind of products and technologies can be
Mm.
used. And at that point, it's about, scale and how kind of complex your power topology is to support those higher power levels.
So, with the new solutions that you guys have been developing, the reference designs and showing engineers that it can solve all these issues, what would you say is the biggest resistance that engineers sort of present to you? Like what stops them from wanting to go on to these solutions?
Yeah. So I think there is the automotive industry in general, as we talked a little bit about at PCIM,
Yeah.
tends to focus on, the safety and quality and reliability of these systems. And so I think in general, it's
Yeah.
a relatively slower moving industry than maybe personal electronics. So I think that part of it is true.
Mm.
And there's just inherently it's going to take like longer for some technologies to be implemented, but part of that is just because the design cycles are longer too. If you're making a
Mm.
wall adapter, that's only one maybe flyback power supply, but that same flyback power supply is just the auxiliary supply within the scope of the entire scooter. So it's a much more complex system, right? And you have different systems that all need to work together. So on a system level, it just takes more time. To
Mm.
kind of get back to your question in terms of, what's kind of a barrier to entry, a very key note in
Yeah.
addition to the other things we've talked about in terms of power density, in terms of efficiency, in terms of meeting the qualifications, the next one I would say is being able to comply with electromagnetic immunity and or electromagnetic
Mm.
kind of compliance standards. So you don't want the switching of your power supply to interfere with your heads-up display, your, maybe
Yeah.
not your speedometer, but your gauges or whatever else is on the vehicle. And similarly speaking, if you have
Mm.
this very advanced microcontroller that is kind of a host of the system and is taking inputs from a lot of different sources, you want to keep the ground and volt and the power rails of that extremely stable so that you can operate the scooter reliably. So that's why, from our perspective, we're seeing a lot of requests from our customers to provide that, EMI compliance data, and in some cases, even showing results that are under those compliance limits because that's what they're shooting for as well, right?
Yeah.
If you set a certain limit in terms of EMI across a frequency spectrum, you want to be under those limits so that when you actually implement it in your full
Mm.
system, you kind of have a little margin, a little headroom, a little extra space to kind of be more confident that across the different corner cases of a vehicle, you'll be kind of protected and
Mm.
you'll have an overall high performing system.
It's interesting. It never really occurred to me that as things like GaN and silicon carbide come in with higher switching frequencies, that's great for reducing the inductor size, whatever, and all this jazz. But then of course you've got a really large power being switched really, really quickly, which almost any engineer involved with EMC compliance will know that that's going to scream radio interference. So it's really interesting that could be a major barrier for people when it comes to picking that as a technology solution. So, I mean, and I'm kind of wondering if you have to sort of put in shielding, for example, that might contribute to system weight, but I can't imagine it being horrendous. And I'm also guessing there are design practices that you can do to reduce the EMC, sort of
Yeah,
EMI
absolutely.
specifically from these kind of systems. So, and I'm guessing that's something that TI can help with as well.
Yeah, absolutely. So across our portfolio of, especially our isolated portfolio, whether that's our flyback, our LLC, our phase shifted full bridge, and even other isolated topologies, most of them employ, what we call, soft switching, right? So we have some solutions in our
Yeah.
portfolio that do, hard switching. So when the voltage across a FET within the power stage is not zero, then you have some losses associated with that. especially our
Yeah,
LOC
yeah.
and phase shifted full bridge controllers. These are, inherently resonant, meaning that there's, inductor and capacitor kind of recycling energy within the circuit to drive that voltage all the way down to zero, so that when you turn off that FET, there's no, or at least less switching losses associated with it for sure. And
Yeah.
that hugely impacts not only the efficiency, it greatly impacts, being able to comply with the EMI standards. It improves that EMI or EMC performance. And so that's something that, we'll
And that's
continue
exactly
to invest in.
and that's exactly where your reference designs come in as well.
Exactly, exactly.
Absolutely fantastic. So just before we wrap up this podcast, I've got one more question for you. For the audience who are watching this video, if they want to get involved with TI Solutions, what would you recommend that they do?
Yeah, so I think we've talked about the references designs a lot, and I think for good reason. I think they offer a good starting point, right? These are not things that are necessarily intended to be, reused or resold, but they offer a relatively realistic picture into what a certain system could look like, especially if you're able to put them together, right? And we have evaluation modules, and for even our digital controller portfolio, right? We have hardware and also software libraries to help you get started and ramp into those designs faster. So and right, the technical documentation piece is a part of it. We have a lot of what we call content and collateral on ti.com to help explain and kind of demonstrate our technical expertise. And then a lot of times those are very helpful resources for engineers, at multiple levels. We have our white papers, which are very, high level kind of marketing focused, all the way down to the very detailed, application notes, design guides, and things of that nature. So yeah, in summary, reference designs, evaluation modules, and if you're somebody that likes playing with code, then yeah, the libraries and kind of digital solutions are also on the table as well.
Absolutely fantastic. Thank you ever so much for being here today with us.